Some people will say, sure, you can talk about ants and beehives as some sort of a collective intelligence, but maybe that's just metaphorical talk. Surely we are a true unified intelligence. We have this nice centralized brain. The human experience of being a unified mind is underwritten by this kind of singular organ. And so, for example, Descartes really liked the pineal gland because there's only one of them, and he felt that was a good place for the unified human experience. But he didn't have access to good microscopy. If he had looked in the pineal gland, he would have found all of these things, so tons of cells. And inside each one of those things, he would have found all of this stuff. And so nothing is unitary. We are all made of parts. And in fact, I would claim that all intelligence is collective intelligence. I'm not aware of any agent that is simply not divisible into other parts, that does what it needs to do sort of in some sort of monadic form. Now, this is a free-living lacrimaria, but you get the idea. It's a single cell, no brain, no nervous system, handles all of its needs in ways that make soft matter physicists and roboticists very jealous. And if we want to say things about our own consciousness and that of even weirder kinds of novel engineered constructs, we need to be able to say something about this kind of creature and what happened to it when it joined into networks to enable it to become the kind of thing that we are. The interesting thing is that while this little guy has all kinds of interesting behavioral properties, it is even made of material that already has some of those properties. So for example, it turns out that molecular networks, never mind cells, the nucleus, synapses, never mind any of that, just molecular networks represented by a small set of ordinary differential equations that describe how each chemical turns other chemicals on and off. So it's just a little network. Even these things are capable of 6 different kinds of learning, including Pavlovian conditioning. And we are using this, we're taking advantage of this in the lab for all kinds of medical purposes, such as drug conditioning and so on. You can train the material inside the cells. So when we think about ingredients to cognition and the kinds of things that go along with significant consciousness, such as memory and learning and so on, we have to understand this did not wait for brains and synapses to be formed. This was in many ways a free gift from mathematics, because the properties of these networks are actually to learn, and the ability to learn from experience in precisely ways that are recognized by behavioral science in terms of habituation, sensitization, anticipation, associative conditioning, all of those things. Those things emerge from the mathematics of these networks. They are not dependent on evolution of the substrate.